Okay, so what is nonlinear regression? A form of regression analysis in which the observations are used to predict the y values by a model in which the parameters enter the equation in a nonlinear manner. So this is the model that we will be using. The two parameters in the model are alpha and beta. Due to the beta parameter entering the model through the exponent, this is what makes it a nonlinear model. So the primary task with nonlinear regression is estimating the parameters. And in order to do this, we will use the linearization method, i.e. the Taylor series and least squares. So here are the steps that we will be using in order to calculate the parameter estimates. So the first step is we're going to collect some starting values for our parameter estimates. The second step is we're going to calculate the Jacobian. The third step is we're going to perform the least squares method to calculate the new parameter estimates. And the last step is we're going to repeat steps 2 and 3 until we achieve convergence. So for step 1, the starting values that we will be using for our alpha and beta parameters are 0.3 and 0.02. The starting values will be used in order to create the Jacobian, i.e. the Z matrix. So the Jacobian is a matrix whose number of columns equals the number of unknown parameters. In this case, the Jacobian will have two columns. The first column is the partial derivative of the model with respect to the alpha parameter, and the second column is a partial derivative of the model with respect to the beta parameter. So I've taken the partial derivatives of alpha and beta here for our model that we've seen previously. So our model is alpha plus 0.49 minus alpha times e to the negative beta parameter times x minus 8. And then when we take the partial derivative of this model with respect to alpha, we receive this expression right here. And then when we take the partial derivative with respect to beta, we receive this expression right here. We're going to use our starting values and the x values in order to complete the Z matrix. So I have created some code in RStudio, which I will link through my GitHub account as well. So we're going to create the Z matrix. Right now, it is empty, but this first column will be the partial derivative with respect to alpha, and the second column will be the partial derivative with respect to beta. So here are our starting values again, 0.3 and 0.02. And I have shown the expressions in the Z matrix. So here's the first partial derivative and the second partial derivative. I'm going to replace alpha and beta with our starting values in the code right here. And then the last step is I will evaluate these two expressions at the x values that are right here in this x vector. So now we have calculated the Jacobian, and we will be able to perform least squares. So just as an example of how the calculation was done, we can see once we evaluate these two expressions at the first value, which is 8, and our initial starting values, we can see that the first row will be 2 zeros, which we have displayed here. So next, we will perform the least squares method using the newly created Z matrix and a matrix that consists of the difference between the Y values and the model function evaluated at the starting values and the X values. So I've done that in the code right here. So here is the model evaluated at X. And then this Y2 vector is what we will be using as the difference between the Y values and the model expressed at the X values. So now performing the least square method, which is Z prime, Z inverse, Z prime, and then multiplied by this difference vector right here. So the result is that we are going to create some new estimates of alpha and beta, and we're going to use these estimates in order to create new Z matrices in order to complete in order to perform least squares until convergence. So now here in the code, we're going to perform least squares. So this is the Z prime Z inverse times the difference Z prime Z inverse Z prime times the difference matrix that we calculated up here. We're just going to run that code, and that will create the new parameters that are added to our starting values. And we keep repeating this method until we achieve convergence. So the mathematical definition of convergence, we're going to use as it's defined in calculus, such that the limit approaches some value, in this case, the parameters, such that the difference between the iterations are negligible. So we're going to do a second iteration. And here are the final values that we received for the alpha and the beta parameter estimates. And as you can see, when we use the nonlinear regression function in our studio, we receive the same values here that we achieve the same parameter estimates that was achieved in the nonlinear regression function in our studio. So this gives you an idea of the math and what is going on behind the regression function in our studio. I hope that illuminates some of the mathematical steps that are used behind these regression functions. Thank you.